morning, and thank you for being here with us today at our 2021 Beyond Big Data virtual event. If you have questions at any time, please feel free to send them to me in the chat feature. We are going to jump right into breakout number 1, part 1, with redefining business intelligence for real-time businesses. And I'm so pleased to welcome our presenter for this session, Bruno Kurtic, founding VP of Product Management and Strategy at Sumo Logic. Bruno, thanks for being here with us on this Tuesday morning. The virtual stage is all yours.
Thank you very much, Allison. All right, I'm sharing here. Just give me a thumbs up. You can see it. Great. All right. Well, welcome everybody. Thank you for joining me this morning. It's early morning over here. I'm on the West Coast. My hope is that this is one of the last presentations in a conference that we're going to be doing virtually, but we all have to do our part these days. So, as Allison said, my name is Bruno Kurtic. I am member of a founding team of a company called Sumo Logic. We are a machine data analytics company. I'll talk a little bit about what we do later, but I'm here today to talk to you about digital businesses, real-time businesses, and how business intelligence is changing for those businesses as they sort of compete in their industries. So I'm just going to dive in, right? So digital transformation is everywhere. Digital transformation just means that enterprises are embedding technology into what would traditionally be called traditional products and services. It might be that it's the products that are changing or services that are changing, or it could be a delivery model or a service model for those technologies. And this is a core issue for the business suite in enterprises across all industries. And this has been going on for 30 years. It's not anything new. It's not a fad. It's not a latest trend, and it's never going to stop, right? Technology is going to continue to permeate products and services, and we're going to sort of continue to see this penetrate more and more industries and more enterprises around the world. So the question is then, what happens to an enterprise when it becomes a digital enterprise, when it starts competing with digital business models in its industry, right? And the primary thing that happens is what changes for an enterprise, that every enterprise that does this becomes a software business. Many of you have probably heard the phrase software is eating the world that Mark Andreessen said sometimes, maybe 10, 15 years ago at this point, which just means that companies are building teams, internal teams that are focused on building custom software, because off-the-shelf software cannot differentiate you in a digital business model, right? Because off-the-shelf software is available to everybody, so everybody's going to have it. And so what enterprises are doing is they're building finely tuned software packages that power their digital services and technologies and products internally, right? That's what they differentiate on. And this is happening, like I said, everywhere. And you can see this probably in your own enterprises. If you are in a quote-unquote traditional enterprise, just look around, browse the job sites and open recs, and you'll see, and just count to see how many job descriptions you see that have in it, cloud or AWS or microservices or Kubernetes and technologies like that. You'll see kind of the numbers of developers that your enterprises are hiring. And so when enterprises go through this process of transforming into digital businesses, they end up going through a process of transforming many things technology-wise and process-wise that they do. And when they do that, the competition, the levers of competitions fundamentally have to be addressed differently. The levers of competitive advantage in digital business are not that different than those in traditional business, right? When you're competing in any industry, no matter whether you're in traditional or digital business, you have to innovate faster, right? You have to be sort of faster at innovation than others. You have to be, delivering better customer experience than your competitors. You might have to be delivering better economics or having a lower cost structure. And you don't have to do all these at once, right? There are businesses that compete in one or two and some in all three of these dimensions, but it doesn't have to be, you don't have to be a business that wins in every one of these dimensions. What's really different about competition in digital is that competition in digital, achieving better rate of innovation, customer experience economics, is very different than how you used to do this in traditional business models. And today we're going to spend a little bit of time on these three levers and how how a digital business achieves this, how it measures itself, how it benchmarks itself, and how it improves to become more competitive as a business. So rate of innovation in digital business is really driven by the company's ability to deliver better software faster to its customers, right? Whether that software might be embedded software inside of a device or it's a retail site, right? And we do this through three primary pillars. And the pillars are Agile software development. Agile software development enables companies to deliver software, new features and new software to their customers faster, essentially delivering new products and services faster. Cloud enables companies not to lower their IT cost, which is oftentimes thought of as the primary benefit of the cloud, but rather as the ability for a company to actually make hardware changes at the rate of software changes. When you're changing your software on a daily basis, you also benefit from being able to change the hardware it runs on, because then your software is more efficient and can be finely tuned for what you're trying to achieve as a business. And last but not least is microservices. And that's it, for those of you who are not techies, an architectural paradigm that essentially does the following. It breaks down the monolithic software packages and applications into smaller services that can be developed, deployed, and managed independently from each other, further enabling agile development and accelerated change rate in your software and services that you deliver to your customers. So this is how you innovate faster with digital businesses. And this area, we can look at how a company can, first of all, understand where it is and then how it can improve. Customer experience is also very different in digital than in traditional business. You know, no longer delivered by quality manufacturing and human based customer support, even though those are still important. Primarily, what I mean by delivering customer experience is through reliability of the primary customer interface. And the primary customer interface in digital is, again, your technology, right? And it could be a retail site, like I said, an entertainment site, or a game, or an IoT device, or whatever. But that the definition of its reliability really is across these three pillars. One is it available? Does it work when it needs to work? Does it perform as your customers are expecting it to perform? And is it secure? Is it protecting your customers' data and your business? And last but not least is the economics. And economics, again, this is probably the most similar to the traditional business, is really driven by, what's your infrastructure cost, what's your data cost, and what's the management cost of managing these technologies that are sort of underlying and underpin your digital services and digital applications that serve your customers. So what's important here is to understand how to measure enterprises' ability to deliver on these three levers, and then do that in real time, because digital businesses are real-time businesses, being able to understand what the data is telling you, being able to pivot and essentially improve. And that means that a business intelligence paradigm has shifted when you work in digital universe. And that means that this data that you're leveraging is very different than the data that you might have been leveraging in traditional business intelligence models, right? This data comes from your entire digital stack, right? It's not just data that comes, from a data warehouse or database, right? This is data that comes from your systems, from your hosts, from your networks, from your cloud deployments, from your applications, from your containers, from your, third-party services like content delivery networks, CDNs, and it's data that comes in different formats. It could be machine log data, it could be time series data, it could be data that describes transactions or metadata, and it's, it comes in form of key performance indicators, key or service level indicators, key risk indicators, events, transactional information. And all of this data is streaming in real time from that primary customer interface. And if managed correctly, can become a tremendously powerful source of business intelligence information that can, across multiple business lines of business in a company, really improve how companies execute, right? SRE, a DevOps team, might be able to glean information about how good is the performance today versus yesterday versus what we really desire. Security teams can look at this data to understand threats that are happening in real time, trying to defend proactively against attackers. Product management teams can look at what are our customers doing with this new product we just launched. How are they behaving? Are they actually, using the product? Are they not? And so on and so forth. So this is what we call continuous intelligence. It's essentially business intelligence in real time, continuously leveraging many more data sets than traditional business intelligence might have. And this is what we think that business intelligence is evolving into when you enter a digital business model. So what I'm going to do now is I'm going to spend a few minutes and I'm going to talk a little bit about examples of this, specific key performance indicators and service level indicators in these three levers. I'm going to talk a little bit about what opportunities those present. So let's start with the rate of innovation. I'm going to cover this sort of across a couple of different dimensions. The first one is really about your software development agility. How agile is your software development team, right? Most companies today would claim that their software development teams are agile teams, right? But how do you know how well are you doing, right? What's the measurement methodologies? Which tools do you use? How do you kind of fine-tune what you do in order to improve and become a better innovation engine, right? And so there's multiple methodologies for measurement, but one of the most closely and well adopted ones out there is a methodology that comes from Center for DevOps Research and Assessment, or for short, DORA, which is part of Google Cloud. And they publish these really 4 KPIs that are in 2 buckets, the agility bucket and the reliability bucket, that describe how well is a software development team doing in terms of delivering agile software, quality agile software. So the measures are following: deployment frequency, that's self-explanatory, and so the deployment frequency just means how often do you deploy per day? Like, more times per day, the better. Lead time just means how long does it take from that moment when the developer is pushing code submit, when they're finished coding something, for that code to appear in production. And that's measured in time, hours or days or weeks, hopefully hours, right? But the shorter the time, the better. And then the reliability measures are change failure rate, meaning how often do you push code to production that breaks production or impacts production negatively. And then mean time to recover is just inverse of that and says, when you break something, how fast are you at fixing it by going to the beginning of your software development process, running through the process, and actually fixing the problem you just introduced, right? And what you can see here is that there is a huge disparity between the best in class, several order of magnitude, sometimes better than an average business, which when you think about a core innovation business, right, in digital, that gap needs to be closed, right? If you are on the sort of average business side, you should understand that there are competitors out there who are orders of magnitude faster, right? And that is an important thing to understand, because software development teams and technology teams are some of the biggest teams inside of an enterprise that compete in digital business, right? So fine-tuning this is extremely important. And luckily, this can be done by mining data out of the tool chain that your development teams use, like Jira and GitHub and Jenkins, and actually making that data measure these KPIs. And we built a solution for ourselves first, and then provided it to our customers, who now can do this and monitor this technology stack, this tool chain, these processes in real time across the entire enterprise, across different teams, across different services, different products, and continuously be able to sort of know where they are and continue to improve and drive better rate of innovation by optimizing this development process. Next step is, let's talk a little bit about the sort of the enabling technologies for rate of innovation. Cloud and microservices, we talked about it earlier. This is a cross-section of our customer base. All of this data from now on is going to be data that we measure inside Sumo Logic, because we are a technology that collects a lot of it, analyzes a lot of data. But I wanted to make sure that you guys understand that all of this data that you're going to see from now on is data that we actually measure. It's not survey data, it's the actual data flowing through our system. So what you see here is that 85% of enterprise, and we serve digital global enterprises across all industries. We have more than 2,000 enterprises that use Sumo Logic, which means that we don't have a biased sample, right? We're not just serving tech companies in the Bay Area, we're serving companies around the world. And you can see here that 85% of those companies are using at least one cloud. And the most important thing here is that almost 20% of those companies are using multi-cloud, and that is the fastest growing segment of all of our customers, right? It's growing 70% year over year. So cloud adoption is accelerating for that very reason, to enable companies to evolve their hardware at the rate of their software evolution. And then furthermore, when you look at other technologies that enable things like microservices, typically microservices run on top of technologies like serverless, which are basically just functions that you can create in code and run in the cloud without having to worry about infrastructure, or running on container technologies like Kubernetes and ECS and others. And as you can see, those about 40% or a little bit more of all of the enterprise that we serve use these technologies to run microservices style technologies to help them decomponentize their software, evolve it faster, deliver it faster, scale it better, right? And this is really exciting, and this growth is continuing, right? But you can also see that there is quite a bit of opportunity to improve, right? You know, why is this not at 80%? Well, you know, level of maturity and so on and so forth, but there is an opportunity for companies who are willing to take some technology risk and move a little faster to potentially differentiate themselves in this space. So this is very much business intelligence for modern business, because this is what's going to help you ensure that you are innovating faster than your competitors and delivering better and newer and faster products and services to your customers. So I want to switch now and talk about customer experience. And customer experience is really, you know, an interesting aspect of competition in digital. And most of our customers, Sumo Logic's customers, use us to deliver reliable software applications and technologies to their customers. And, you know, a lot of them are running in the cloud, as I said, and here you go, you're running in the cloud, right? I took these screenshots yesterday just to be fresh. You know, you now are running in the cloud, and, you know, everything looks green, everything's available. We can all these, you know, sea of green check marks, everything's super, right? You never have to worry about anything being unavailable in the cloud, right? Like you sometimes said in your data center. Well, you know, that's not really the reality. And, you know, when you really look at, you know, we wanted to, because we serve our customers and help them manage their cloud deployments, we have this privilege and privy to be able to understand what's actually happening in the cloud. And so here there's a anonymized cloud, you know, it's one of the big ones. You know, this chart represents almost 30 regions around the world of the specific cloud provider. And this is just to show you that we've been measuring service availability, service throttling, and compute out of stock response codes to API calls that our customers made to understand what's the real availability and reliability of the cloud. So in any specific region, you could actually run into 1% to 2% unavailability or throttling, which means that, you know, the cloud provider is saying, like, back off a little, you're asking me questions too quickly, right? Or if you're spinning up some compute, you want auto scale because you have a burst in your business, it's responding to it saying, I don't have stock, I cannot give you those instances, right? And that can have a major impact on a business that is trying to deliver reliable application to its customers when the backend isn't able to serve them properly, right? And so you have to architect around this. This is one of the reasons why enterprises are moving to multi-cloud, right? They're architecting around these issues, and what they're effectively doing is they're buying themselves an option. If I run out of stock of specific type of instance type that I need over here, I'm just going to get it over there, right? Or if I'm running out of API calls, they're being throttled in this region, I'm just going to go and serve that workload from that region, right? This is what enterprises are doing through these architectural paradigms, microservices, and essentially adopting these new technologies. Let's look at security as well. Security, we help our customers manage security for their cloud deployments and their digital services and workloads. And we wanted to understand sort of how is security changing? How is security changing? Are there any trends that are worthwhile noting, right? And we mapped on the left, you will see that we mapped here a pre-COVID threat framework called the MITRE framework, or called the MITRE attack framework, that categorizes threats in IT into buckets. And then we wanted to look at what happened when we all went into lockdown. It was really fascinating to see this. Within just a few weeks from before shelter in place and after shelter in place, when the tremendous change in how we do our jobs happened, right? Instead of being inside of a company behind a firewall, now we're sitting at home, we're changing location, all this stuff. the threats that have been affecting our businesses and our applications have also changed, right? Quite a bit in many cases, right? The attackers are evolving and they're evolving to adapt to the new conditions. And so is the security evolving, right? Our customers had a tremendous need for change in how they secure their specific workloads and how they secure their workforce as well as they were going into shelter in place, right? And so again, this is to underscore that the reliability is, you know, an important dimension of a digital business and how it competes. And this is very much a C-suite concern, right? This information that you can glean and benchmark yourself and then continue to improve upon is something that will drive success in competitive advantage in digital business. And now I'm going to move into the last section of at least data. And again, this is data that we collect and we analyze. And we wanted to talk a little bit about competition now, and not competition, sorry, about economics, right? So, you know, economics in digital, as I said, you know, I have a couple of dimensions. And here we're looking at infrastructure costs, right? And infrastructure costs are interesting in digital. You know, it's no longer about how cheaply can you buy a server. Now it's digital businesses are real time. They go through business cycles, daily cycles. If you're a retailer, you might spike at the end of the year. If you're a gaming company, you're probably going to spike when kids come back from school. If you're a SaaS software provider, it's going to spike during the business hours of the day, right? And as that happens, you know, techniques exist today that can help you manage that cost and map the cost of your business to your business cycles, right? And so we wanted to look at auto scaling, for example, as a proxy for how effective are people in managing their economic cost of their infrastructure. So here you see on the left, this is the percentage of enterprises that are auto scaling their cloud compute, meaning they're auto scaling their, you know, EC2 instances or Google Cloud instances or whatever they might be. And you can see that almost half of the enterprises do that. And on the right, we wanted to look at deeper as are any of these enterprises also scaling more sophisticated services like databases and queuing systems and things like that. And what we learned is, as you can see here, that many fewer are, and there's a lot of opportunity here, right? You know, what's really astonishing to me is that there's almost 55% of enterprises here on the left that are running their cloud instances the way that they used to run their servers in a data center, right? If it's not being used, it's just sitting there chewing up, you know, power and whatever. And here you're paying for it. When it's sitting in the cloud and doing nothing, you are paying money to those cloud providers at the same rate as if it was doing the most amazing thing that you needed it to do, right? So it's really important to improve this and to optimize and to gain that leverage in economics. And similar is true in Kubernetes. Like Kubernetes is actually designed for auto scaling, and we wanted to just see how is this happening in this technology stack that is designed for scaling and auto scaling and dynamic provisioning and all of that. And you can see here, if you look at kind of across tens of thousands of containers and pods in Kubernetes clusters across our customer base, we found that only about a third, actually less than a third, are optimally provisioned, right? All of the red ones are under provisioned, they're incurring risk. All the yellow ones are over provisioned and they are probably overspending. And it's just that blue band of somewhere between 15 and 30% that is actually optimally provisioned based on how you should technically run your Kubernetes clusters in order to get the right performance, but also not overspend, right? And so all of this is to say that, you know, ability to understand what's actually happening, how are your teams innovating, how are your teams delivering reliability and excellent customer experience, how are you provisioning your infrastructure, can tell you a lot about your business, can give you a lot of improvements area for your business to drive competitive advantage in your industry, right? And again, going back to this original picture, this is what you need to start looking at as a digital business. You need to start thinking about collecting data from different types of sources of different types, leveraging different level of scale to analyze this data. Think about this in real time to really kind of feed those signals back into your software development lifecycle, your operations team, your security teams to continue to improve and differentiate in this market, right? And so I'll stop here. I don't know if there are any questions, but just for final thought is, again, Sumo Logic is a cloud-native machine data analytics company. We leverage, you know, machine learning and cloud technologies to help our customers analyze these types of data set and serve their digital businesses. So if there are questions, I'll gladly take them now.
Thanks so much, Bruno. We have about 2 minutes left. So we have one question that came in from Ray Millam. He says, great presentation. Thanks for being here, Bruno. What is your competitive advantage versus Datadog, Splunk, Elk, etc.? And thank you.
Great question. How much time do we have? Our competitive advantage is really scale and analytics, right? We are an analytics company. We began the journey into analysis of this data by having to deal with unstructured log data generated by infrastructure and applications. And that's the hardest part. That is the unstructured nature of this data. And you can see here some numbers, right? We analyze almost an exabyte of data per day, which is some 1.7 quadrillion records queried daily. And so it's that scale and the security of our platform itself that enables us to serve customers like the ones you see on the screen here, companies like Visa and New York Life that are pretty sensitive in sensitive industries that have sensitive information. We are the trusted partner for those technologies to collect all types of data like logs, metrics, and traces, and do that at scale with performance and security.
Wonderful. That is the only question we had in, and it is right on time for our 10:30 session to begin.